Yeah, okay, we are good to go. Yeah, so, uh, okay, yeah, okay, great. Yeah, so now the recording has also started. So, good evening, everyone, and let's start week six's session. I'm Indrani. I'm a research scholar from IIT Bombay, and we meet every Tuesday at 7. Um, I upload the recordings on YouTube mostly by Tuesday night, latest by Wednesday morning. Yeah, so. Okay, so I have covered these points many times, but still we practice the assignment questions and the program. We try to understand the algorithm and the code for programming assignment questions uh, every week, so that it helps us in understanding or anticipating the final exam questions. So there are some etiquettes which like all mostly I see many of the repeated names, familiar names. So you all are well aware that I keep a tab on chat. In my screen recording also the chat is visible, so your messages will not go unnoticed and will be responded to all the queries. So avoid unmuting unless it is asked for, because it's little disturbing, and it also, you know, destroys the flow. So without further ado, shall we go on to solving the assignment quiz first? You can raise your hands, or we should wait for, because we have just 18 participants. Okay, great. So I got a couple of yeses, so we'll start. Okay. Okay, great. So this was the last run's assignment. So last run for this course was last semester. Okay, so these are not very old questions as such. So you can expect similar questions in your current assignments also, as well as in your exam also, right? So we are familiar with such kind of questions. Yeah, so Hasani ji, these YouTube recordings are shared on Swayam portal with live problem solving sessions. There is one another tab at the end of the left hand side options. There is a live problem solving session tab which takes you to the Excel sheet where we update YouTube records links in front of our names. All the TAs do, so you can watch other TAs recording as well. And I also upload it every week, so all of us are supposed to keep the session recording for everyone, for benefit of those who couldn't join the live session. Okay, so we'll again come back to question 1. So what this code will do? Okay, so let us try to understand what this code means here. So
Please tell once again. We can't able to hear.
I'm not audible.
That is the recording sessions.
Recording sessions. Oh, okay. So the recording is uploaded on YouTube, and the link to those YouTube videos is updated in the on the Swayam platform. On left hand side you see week 1, week 2, week 3, and so options. So at the bottom of those left hand side options you will see one of the option named live doubt solving sessions. Yeah, live doubt solving sessions. So when you click on that, the message opens, and there is a link for to the Excel sheet. When you open that Excel sheet, there are week wise recording of all the TAs shared. Okay, and that will give you access to the PDFs which all of us use during these live sessions. Okay, so you will get to see these PDFs which I use in every session, and from there you can also go to this thing also, YouTube channels also, and then you can get update, or you can go through previous week's recording also. So once you get one YouTube link, I think maybe through the channels you can access the all the week's recording. Yeah.
Yeah, thank you, ma'am.
Okay, so now coming back to the question. So we are defining a function called shift, whose arguments are the word and the value. Okay, so let's understand what the word is. Word means the word which we want to what this function is doing. Let's see. So in that function we are defining letters, string of letters, lowercase. Okay, so all the lowercase letters. Okay, and new is the another empty string. So this is what we call initialization in programming language, right? This is initialization of a string called new. Okay, we are declaring and keeping it empty, so we are initializing a string called new. So now this for loop will be executed for all the letters in the word, right? The word, we will measure the length of this string word, and for this length this for loop will be executed. So if the word is 5 letters long, this for loop will be executed 5 times, and so on. So now we are checking the condition if the string word has the index I, the letter in the index I is part of this ASCII lowercase letters. So if this letter, okay, this word I points to a letter or alphabet, and we are checking if that alphabet is lowercase, right? So what if it is lowercase? Then if this condition is true, then these two statements are executed. So now index is another variable. So what this index is storing? Index is storing letters dot index of word of I. So this word, the current letter in the word. So if the word is word, then the current letter, like 0th letter, the first letter at index 0 is W. So this W's index from this letter, from this reservoir of ASCII codes, right? So that value is stored, that index value is stored in this index variable, and then we are calculating new, the value of new. New is a string. New is old new. This is old new. This is new. So old new plus letter of this index value, right? This is the index value, and we are calculating the alphabet or the letter which happens to be at this index value, right? Alphabet or letter which happens to be at this index value. So now can you guess what this mod 6 is doing, mod 26 is doing? So mod 26 will make sure we have 26 alphabets, so it will make sure that we are getting workable value and not some out of bound or out of index value, the ASCII value. Okay, so that's why we are using this mod 26. So what it is doing is it is shifting the index with the value, right? So every letter in the given word, it is getting shifted by this value, because that is how we are calculating the new index, right? So if we want to shift the every alphabet in any word by 2, then we will pass this value as the argument here. So this is the shifting value, right? So now can you guess which of the options will be correct? Okay. So I'm getting suggestion that we should be using yellow color. Okay. So I'm picking yellow color. Yeah, I think now it will be clear. Okay, yeah, great. Thank you, Virendra ji. Now I think the yellow color, is this yellow color visible here on the white also? So we'll stick to the yellow color now. Okay, yeah. So this is what is happening. So okay, so now let us have a look at the options. So many of you are saying A, and one of the options is returns the same word. No, it will not return the same word, Pradeep ji, because it is shifting the ASCII value, the index value of every letter by value. So the correct answer would be option A. The every letter index is getting shifted here, no? In this statement, we are calculating new string as we are appending letters of this index value, right? Index plus value. Let me erase this so that you will be able to see, right? This is the index value, and we are adding this value variable here, and then calculating the new index, and whatever letter is at that index, we are appending it to this string called new. So that is how every letter is getting shifted by the value, right? So the correct answer is option A. Okay, so moving on to next question. What will be the output of the following code for the input, the joy of computing? So now let us understand what this program or what this function test is doing. So it is having a word or a string as an argument. This would be input. In our case, this can be the joy of computing. This is what we are asked. Now we are storing all the lowercase in the string called lower and all the uppercase letters in the string called upper. Okay, and again we have initialized this new word, the string called new word. So now for every character, so ch is every character in the string word. Yeah, so this is the every character in the given or input string, right? This is the input string. So we will check if the character is lower, when the character is part of the lowercase alphabets. Okay, if it is lower, then we are getting its index and storing it here, right? Index in the or the position in the this lower string. So that will give us the ASCII value of that particular letter. So now we are calculating new word. So what it is doing, it is adding it to empty, it is appending. This is used to append the string with the letters. So what is happening here, index plus 2. The original index of this was the original index. The original index of the letter or the character, and we are adding 2. 2 is getting added. So that means we are shifting, we are moving it ahead by 2, right? And this will give us the round robin alphabets, like mod 26 will keep us within the limits of A to Z. So now for lower alphabets, like for lowercase letters, shifting by 2. This is happening. Now what happens when the character is uppercase? So uppercase, again we are finding the index, we are getting the index. Now what we are doing is we are adding 3 to that index and then converting into character and then appending it to new word. Yeah. So shifting the letter, the uppercase letter by 3. Okay. So we know we are shifting lowercase by 2 and uppercase by 3. So what will happen to the joy of computing? Capital T will get shifted by 3 letters, right? So T, U, V, W, it will become W, capital W. Now H is a small, not uppercase, like small case, lowercase. So lowercase will shift by 2, right? Lowercase will have lowercase will have this letter shifted by 2. So H, I, J, so it will become J. Then E, F, G. Okay. So there are two options, A or option C, option A or option C. Okay. So now we have to calculate joy, capital J. So J will be shifted by 3 letters, right? So it will be shifting thrice. So what will happen? J, K, L, M. So it will be capital M. O, P, Q. Because it's lowercase, so it will shift twice. Y will also be shifting by 2. Y, Z and A. So Y will become A. So M, Q, A. Both A and B have similar thing. So now it depends on translation of off. So both O and F are capital. So both will be shifting by 3 letters. O also and F also, right? So O will become OP, O, Q, R, right? So O will become capital R and F will become F, G, H, I. It will become I. So that gives us option C, right? So that is how we come to option C. So I see, okay, yeah, so Vipul already corrected his answer to option C. So Sivdarshan ji, you are you still with option B or you're with me with the option C? because there are capital letters, so different rule for capital letter and different rule for small letters. Like for uppercase letter, the every letter will be shifted by 3 positions, and for lowercase letters it will be shifted by 2 positions, right, ahead. We are adding, so that's why the calculations will be different for lowercase and different for uppercase. So you have to we have to go through the code carefully. So that gives us the answer as option C. Okay, so moving on to question 3, which of the following is true about recursions? So assuming that all of you or most of you have watched videos for this week, week 6 has a lot of videos on recursion, how the recursion works and what is recursion. So maybe those who have watched the videos can give the correct answer. Which of the following is true for recursions? So I will read out the options. Option A says recursion increases speed of the program. Option B, recursion decreases the speed of the program. Option C, speed of the programs remains the same. And option D, recursion is easier to understand than non-recursive programs. Right? So almost all of you are correct. Answer B, recursion decreases the speed of the program, but it is not easy to understand, because recursion means calling a function recursively. Right? When you want to do some actions repeatedly, we use for loops. In the for loops or in while loop, the certain set of actions are doing again and again. So similarly in recursions, what we do is, in every iteration of a function, we again call the function. Right? So what happens there is, we will be defining a function, and we will be passing one argument called n, and then within that function we will have one stopping condition, right, where to stop the execution of the function, right, where to stop the execution of the function. And then we will have a return statement as part of this stopping condition, and then we will again, like this, if stopping condition is true, then return value. Else what we will do is, we will again call the function with the modified n. This is the new n, this is the old n, this is the new n, right? So we will recursively call these functions. So what happens is, when we recursively call the function, it becomes more efficient, right? Because that is where the access to the variables and the kernel level, at the kernel level or at the processor level, the function becomes faster. Yeah, so we are not decreasing the program, but we are increasing the program. We are making the program more efficient. Yeah, so try to understand, this is one of the features of the recursion. That's why when you want to optimize a certain set of tasks or certain code, you are advised to use the recursion. Okay, so all of you who think it decreases the speed of the program, it might decrease understanding, the level of understanding of the code, because we need to have certain things in mind. What is the stopping condition? And because when we define the stopping conditions correctly, you just have to check the one condition, and then again, you can again call the function, check the condition, call the function, check the condition. So so the processor knows what to do, and it repeatedly it does the set of actions faster. So that is how the program is made a bit faster. Yeah, so it is one of the optimization techniques. So correct answer is answer A, right? Recursion increases the speed of the program. Yes, it is easier to debug, because we have to check the condition and the return statements. What is the part of the return statement, right? So it becomes easy to debug also. So it is easy to debug, it is easy to execute. So overall it makes things easier if you think like a computer, or if you define your recursive function properly, then it becomes easy. But to define a recursive function, you require certain level of expertise in algorithmic thinking. You need to think about the algorithm thoroughly, and then translate that algorithm properly into the code. Then it becomes easier. So once you understand what is the recursive function, it will not remain that of a difficult task, even to understand how the recursive function comes. Okay, so now in a few of the next questions, we will be seeing how the recursive function works. So at that time, you will understand that thing in detail. Okay. Yeah, so again, a recursive function has come up. So we'll get to see how this function is getting executed. Okay, so as I was telling, every recursive function must have a stopping condition where you should, because we are again repeatedly calling that function, within the function, we are calling it again and again. So at one point of time, it should stop the execution, right? It should stop what it is doing and then return some values which is expected out of this. Okay, so Vipul is saying recursion is using stack concept in the background, so it is really increase the speed. Yes, it does increase the speed, because we are not modifying the same variables again and again. We are not accessing a stack, or the array is getting accessed once. We are pointing towards the beginning of the stack and the end of the stack, and all the values are calculated and stored in that stack or array. So it becomes easy to assess the values stored in the array or the list. That's why the speed increases from the memory point of view. Because the most time goes into accessing the variables which are stored in the memory. So if we kind of minimize that time in the memory access, our program becomes faster. So that is the precise reason why recursion is faster. Yeah? It's okay if you don't understand what I just said now. That's absolutely fine. But the bottom line is recursion makes the program faster. Yeah. Okay, so now let's see how this recursive function is getting executed. So we are checking the condition. If number is equal to 1, then we are returning this 1, the value of number. Otherwise, we are returning number multiplied by number minus 1. Okay, so there is one mistake here in this code. This number minus 1, this return statement should have been return number multiplied by recursive of number minus 1, instead of just number minus 1. Okay, then if we make this assumption, then we are able to deduce what this function is doing. Otherwise, this really returns the value of number which is the argument of the function, multiplied by one number lesser than this. Yeah, so it becomes so that is not in the option. So we will assume that by num minus 1, they mean we are calling this recursive function for the argument num minus 1, one number lesser than the current argument. Okay, so what happens is, on the first run, so let's assume num as 3, right? Num is equal to 3. So we are executing recursive for number 3. So we are checking this condition for 3. 3 is not equal to 1, so this is false. So we are coming here. So what it will return? It will return 3 multiplied by recursive 2. N minus 1 is 3 minus 1, 2. Yeah. So for recursive 2, again we are calling recursive function for argument 2. Okay, so what will happen? It is checking, this condition will be checked. If number is equal to 1, no, this condition is false. So it will again return 2 multiplied by recursive function for 2 minus 1, 1. Yeah, it is happening here in this call, recursive num minus 1. Okay, so now for recursive 1, it will be executed. It will be checking this condition, if number is equal to 1. So yes, this condition becomes true. It will return 1. So now here in the final execution, I am writing answer here. Okay, so 3 multiplied by 2 multiplied by 1, because this just returned this value 1, right? So multiplied by 1, which is 6. So which is the product of first n numbers, right? Option B. So it is representing factorial sequence of given number. Yes, Shivadarsan, this is kind of multiplying all the numbers till 1. 1 multiplied by 2 multiplied by 3 multiplied by what was the argument of the function, right? So this is how the recursive function works. So we are calling we are just calling from the main function just once, but within the call of that function it is getting called again and again, and when it is stopping for this condition, this is the stopping condition for this recursive function, right? If when number becomes equal to 1, you have to return 1 to the main function where it was called, to this return value. That is how we got to the final answer, which is 6, multiplication of all the number less than 3. So that means first 3 numbers, so first n numbers, first n terms, right? So the correct answer is option B. Okay. So moving on to question 5, what will be the output of the following code? So again,
55.
yeah, yes Aditya, you have some doubts?
No, sir, ma'am, I was getting the answer, ma'am. Answer is 55.
Okay. Yeah, so we have other doubt by Hemanji. He's asking what if the number is a fraction? Okay, so we can take care about that. For right now, for sake of simplicity, I assume the number is integer. So if number is fraction, the -1 will return some float value, right? So for sake of simplicity, we will make sure this is just definition of recursive function, right? We are not calling that function from the code. So when we call, we make sure that we pass argument in the form of integer, right? Because for fraction, it will not give proper answer, because this stopping condition, that number equal to 1, will never be true, right? Will never be holding true. So it will maybe give some error in execution, or will run in infinite loop. Yeah, we'll have to try for the you can try this code running in Colab or your Jupyter notebook, and then try inputting some fraction and check what happens. My hunch is that it will give some error if you're not passing on integer, because we are just reducing, we are just subtracting 1 by it in the recursive manner. So it might give some error. Yeah. So coming to question 5, so again there is a recursive function which has got list L as the argument, right? Now when the length of L is equal to 1, that means the list has just one argument, right? When only one argument is left, it returns that element. So this is the element at 0, that means first element, right? When length is 1, it will return that first element. Otherwise, what it is returning, so this would be our stopping condition. Otherwise, what it is doing, it is returning the it is first element, and then adding this 1 colon, it will remove the first element and returns remaining strings or the remaining elements. So if 1, 2, 3, 4, 5, 6 to 10 is the argument here for the recursive function, so for first run, the length is not equal to 1, but length is 10. So what it will do, this is the L0 for the first run. So it will 1 plus it will call from 2 to 10. It will remove the first element and it will consider all the list from the index 1 to end. So this L1 colon, it returns list from first index to last index. Okay, so currently the list index starts from 0. So 0th element, that is first element, is returned here, and the remaining string is passed on as the argument to the recursive function again. So in the second iteration, the first element will be 2. Similarly, third iteration, this will be the first element will be 3. So these all elements will get added. So the final output would be, let me just write here, the final output would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So at 10 what will happen? The list will contain only number 10. So length of list is 1, the condition is true, and the 0th element or the first element, which is 10, is returned. So at the end this 10 will be returned. At the end this 10 will be returned at the stopping condition. So we are adding 1 to 10 number. So the answer of this code would be that what it will be displaying, number 55. Yeah, all of you agree? Number 55. I see all the correct answers in the chat box. All of you agree with me that the 55 would be the correct answer, and yeah, okay. Ananya is asking, when nothing is mentioned, Python takes it as integer value. So if we don't mention the data type, it has something called as object value. By default, Python data type is object. So object could be anything. It could be string, it could be a set of characters, it could be boolean, it could be anything. So object is the default data type for Python. So that's why when you want to, an object is the longest element. So when you want to make your program optimum, that's why you need to specify the data type. That's why we typecast when we input anything from the user. Yeah, you remember in earlier weeks when we accept input from the user, we use the typecasting method to convert that into integer before we try and interact with it, or we try and process that particular input. So that's why integer is not the by default data type in Python. Yeah, so you have to be careful while working with Python, because to make it more coder friendly, when you deal with the object data type, it could be anything like number, it could be anything. So when you want to process or if you want to modify that data type like addition, subtraction, division, modulus, so that's why it is advised that you at least typecast any integer, or when you typecast it into integer, or when you are accepting the input, then also typecast, or when you are declaring within the code, within the program, then also you declare appropriate type for that. So you don't have to, like Java, you don't have to explicitly declare like int n or int l or int index, but here you can like index is equal to 0, so it will again store that as an integer because you are initializing that as 0. So if you remember in previous questions we had this, yeah, new word is equal to blank. So here also new is equal to empty, just the single quotes, and there's nothing, not a single space in between. That means this is the string data type, because we are declaring like there are quotes, single quotes or double quotes is used for string, so we are declaring it to be a string. So we can do all the string functions with this new string. Yeah, so that is how we tackle the declaration and initialization in Python. So we are done with the question 5. So moving ahead to question 6, what will be the output of this particular program, right? So here it is very similar to this program, but here the only difference is we are declaring L minus 1. So what this minus 1 index returns? Anyone? You can type in the chat.
The last value of the list.
Yes, absolutely correct, Aditya. It returns the last value of the list. Right, so it is returning this 10 in the first iteration. Okay. So this will be the first iteration, the 10 value it will be returned first iteration. No Vipul, index out of bound doesn't come. Oh, thank you Ananya, happy Teachers Day to you too. All of us, we keep on teaching and learning from each other, so happy Teachers Day to all. Yeah. So index out of bound doesn't come for minus 1, because minus 1 is considered index of the last element. But if you go below minus 1, it will give error, but not for minus 1. Yeah? So minus 1 always gives the last element. Okay. Yeah. So first iteration will return this 10 value, and like this 1 : it was returning index 1 to last index. Similarly, L of :minus 1, it returns index 0 to second last index. So here in this case, this will be the new L, because element 10 has been, L minus 1 has been taken out. So it is slicing. This is, we call it as slicing of list or slicing of string. This is how it happens. So we are dealing with the indices of the elements. So when we are using colon or anything like that, when we are using colon with the index, we are slicing or we are breaking that list there. Okay, so what we are doing is we are breaking the list as -1. So this -1, this is out of the list, and now new list will be from 1 to 9. So this is the slicing operation. So this will be the second iteration argument. So second iteration argument will give L-1 will be 9. So this will be the second run. And we are multiplying here. Yeah, we are multiplying here. So first run will return 10, multiply by 9, multiplied by 8, 7, 6, 5, 4, 3, 2 and 1. Yeah, so all the elements, a last element, L-1. So here we don't have to explicitly define the stopping condition, because our first condition we are considering the last element. So when all the elements in the list are exhausted, it will stop. So that will be the list. So this slicing operation or the index will be the stopping condition for us, for this recursive function. So it will stop when it reaches the end of the elements. When the list elements are exhausted, it will return the entire multiplication of 10 into 9 and so on. Okay. Oh. Okay. So I made a mistake here, and I am surprised that nobody is pointing out. So what is the multiplication of all the numbers till 10?
And 3628800.
Is it correct? 3628800. Can somebody check on calculator and tell me?
It is basically factorial, ma'am.
So it is correct, right? Okay, so all of you agree that the answer would be option A?
Ma'am.
Okay, great. Okay, so I thought I made some mistake in, so might be I did not check the multiplication, so I thought the answer is not in the option, so I thought I'm making mistake somewhere. Okay, but we did not make any mistake, and our understanding was correct, and the correct answer would be option A. Yeah. Okay, so coming to question C, what is the search code of binary search? So binary search we have been doing from last week, right?
Ma'am.
Okay. Yeah. Okay, so Vipul, even I think it might give some error, because I am also okay, let's again go through and let us check if the stopping condition is correct. Okay. Yeah, so for first run it will give 10, second run and so on. So what happens when our list is just this, L is equal to 1, when we have this in the list? Let us see what happens. So recursive L will have just one element, so L-1, so this is 0, like for L is equal to L just one condition, right? Just one condition. So L of -1, there at that time I think it will run into infinite loop, because it will not know when to stop. It will not give syntax error, because syntax error there is no syntax error. Syntactically we are correct. There is nothing wrong with the this statement also, the slicing statements also, but it will is it giving syntax error? Okay, let's try okay, when we will, let's keep this question on hold. I'll just mark it as a star, because even I think it will give some error for L is equal to 0 for the last run. It should run into infinite loop, because there is no stopping condition defined properly, or it will give syntax error, two of the options. So we'll try to run this when we practice our programming assignment. Okay, so right now let's keep it on hold. So but what we learned new thing here is the slicing operation. Okay, the slicing operation wala thing is correct. So you should just one thing which we learned here was the slicing operation. Okay, so let's check if this is on the if this is this gives any error or not. Okay, so binary search, okay, I'm okay. So okay, so did we do binary search? No, we did bubble sort, right? Yeah. So even for binary search we need our input to be in the sorted way. I think it was binary search. No, it was bubble search. Okay, fine. Doesn't matter. Okay, so what binary search does is binary search will divide our all the elements in the list into two at the middle, and it will see if the element is greater than or lesser than the middle index element, and if it is lesser it will just see the lower half or the first part of the list which is lesser than the middle element. Or if our element which we need to search is greater than that middle element, then it will look for the elements which are above the middle, the later half, the bigger half of the list. Okay, and with that element again it will check with the middle element if our number which we want to search is greater than or less than. Okay, so that is how the middle that is how the binary search happens. Okay, so see, for example, our list is 1 2 3 4 and 5, and we want to search for the number 4. Yeah, so how it will, so this is our list in the sorted form. So we will see what is the middle element here. So middle element is 3. So we will compare if our number 4 is less than 3. So is this condition true? No, this condition is false, so nothing will happen. But if it would have been true, then we would have considered this 1 to 3 wala list. Yeah, 1 2 3 wala list for searching, for looking for our element. But now 4 is greater than 3, so that means we need to look for the larger portion of the list, that means greater than 3 part. So we will look for 3 4 5. We will look for 5 in this smaller list, 3 4 5. So now we will again check with the middle element. Middle element is 4. So now if the number which we are looking for is equal to middle element, yes, true. So we will now we have the index of the middle element, will return that as the answer, that okay, we have found this here at the index number 0 1 2 3 at the index 3. Yeah, so index 3. So that is how the binary search works. So you know the tree, it will work like a tree, it will traverse the tree like that. So now I have explained, I have given you explanation how the binary search works. So I just have answer from Ketki. Ketki is saying C, right upper option. So Ketki is saying this. So let us say A, B, C and D. So now can all of you suggest what will be the correct answer? Is C correct answer? Let's try to understand. Start plus end. So we are finding the middle, right? Then if start is equal to end, that means we have exhausted the list. The element is just one list. Okay, then we have found the element. Okay, otherwise if middle element is what we are supposed to find, this is what does this mean? If the middle element is what we are supposed to find, if that is true, then we are returning the middle, yeah, the index of the middle. Or if it is greater, then we are considering middle plus 1, that means the later half of the list. So this is also correct. Else we are returning the lower half, like from starting, the beginning portion of the list, from starting to middle minus 1. Yeah, that is what is happening here. So yes, all of you are correct. Correct answer is option C. Yeah, so all of you agree how this is working? So for this you need to understand how the binary search works first. Then you can tell me the correct code, or then you can verify the correct code. Okay, so binary search, why it is named binary? Because it will break the list into 2. Binary is 2, right? It will break your given list of elements into 2 and look for the element in the separate shorter parts. Yeah. Okay, so all of you agree? Should we move on to next question? Because I am not able to see any doubts. So okay, let's move on to question 8. So what will this code do? Yeah, so this seems to be the stopping condition. So what is the stopping condition? When length is lesser than or equal to 6, then it will return the last element. Otherwise, what it is doing, the last element and slicing it till last element. Okay, so we are again, let us try to execute this for the 1 2 3 4 5 6 7 8 and so on, like 1 2 3 4 5 6 7 8 9 and 10. Okay, so now let us understand what is happening here. So this is returned in the first iteration, first call of that function. Then it is sliced, the list is sliced from 1 to 9. So 9 is returned on the second call. This is third call. Yeah. So because this condition is still false, because we have 8 elements, so after third call we have length is 1 2 3 4 5 6. So in fourth call again it will be recursively called. Yeah. So when we are 6 elements, 1 2 3 4 5 6, then what happens is it is less than or equal to length is equal to 6. So the condition is true. It will return a last element, which is 6th. Yeah, 5th. So now length is 5. Yeah? So it will return L minus 1 and stop there. Yeah, for 6 it will return and it will stop its execution because there is a return statement. We are not calling it again. We are not calling that function again. This is the stopping condition. So at this value, we will stop. Yeah. So now we need to see at what index it is stopping. Yeah. So this is index 0. This is index 1, 2, 3, 4 and 5, 6, 7, 8 and 9. Right? The index starts from 0. So it is stopping at index 5. So it is giving us multiplication. This is the multiplication sign. So it is returning the multiplication of the elements from the index 5 onwards. So we don't care how many elements are there in that this particular list, but it is returning all the elements from the last element, right? And it is stopping at the 5th index. So it is returning the product of all the elements from 5th index onward, the multiplication of all the elements from 5th index onward. So the correct answer is option A. So there's a lot of background noise at my end, so I'm just going to shut down the window. Yeah. Okay, so Ananya, you still think the correct answer is option B? And Sivadarshan ji, you said option C before and then you changed your answer to option C again. Okay, so that was a previous question. So you think option C. Option C says returns the product of elements 6th index onward. So I think no, that is the misconception. The element is 6th, but the index is 5. It is a 5th index onward. Yeah. So Ananya, are you still with option B? Returns the product of elements 1st to 5. Because see, this return statement is returning the last element of the list, yeah, not the first. So we are dealing with the list from behind, from the opposite sequence. The last element will be returned first, and we are stopping at this. Length is less than or equal to 6. As soon as the length becomes 6, we are stopping. Yeah, at that point we are returning. We are not executing that condition again and again. Yeah, at that point we are using the return statement. So we are stopping when the length of the list becomes 6. That means the last element of the list is having index 5. Yeah, even though the length is 6, the last element will have index as 5. length of last element will only fifth and sixth element as return. No. Okay, so I don't know why this is very simple. I don't know why there is so much confusion. Okay, so let us try to understand this. Let us have look at this statement. Okay, this is what is going to happen. Okay, we have input list as 1 2 3 4 5 6 7 8 9 and 10. This is the input list L. This is what we have as input. So when the function is called, we are passing this list as argument here. So it is checking if length of L is less than or equal to 6. Currently length of L is 10. So this condition becomes false. So we are not executing this, but we are coming here, return the else part. Okay, return L of minus 1 index. So minus 1 index is the last element of the list. So what is the last element here? 10. You agree with me? So this is the last element for the first iteration. Now this is separated, and what we are doing is we are calling this recursive again. We are using the slicing function for list from the first element. What does L of colon minus 1 mean? From the first element, we are stopping at the, we are slicing, we are making the minus 1 element, the last element, as a separate list, and we are stopping before that. So there are two lists. So one is this and one is this. So this we have already returned. So now new list is 1 2 3 4 5 6 7 8 and 9. This will be the new L. For this, the last element L minus 1 will be 9. Yeah, this will be the last element, and second iteration, this value L of minus 1, this will be the second iteration value. So after that, our L becomes 1 to 8. Yeah, you agree, Ananya? This is how it will happen. Do you agree? So now I will come to, yes, from 5th to 10th, not from first. We are not dealing from the first. We are coming from in the reverse direction. Like we are considering the last element first, and then we are moving backwards, and we are stopping. For us, the stopping condition is when the length of the list, the number of elements in the list, becomes 6. So when there will be 6 elements, what will be the index of the last element? 5. Yeah, you all agree? The last, when we have 6 elements in the list, the index of the last element is 5. So it will return the product or the multiplication of all the elements 5th index onwards. Okay? So nobody has any doubt now? All of you understood how this code will work? Okay, so I am assuming no one has doubt because nobody is typing in the chat box, so we'll move ahead. Yeah. Okay. So it's a statement. You have to agree if it is true or false. Okay. A program which is written in a recursive manner cannot be written in non-recursive manner. So is it true or false? Okay, so I got quick falses. Very good. All of you agree that it's false. That means yes, absolutely every recursive program or recursive code can be written non-recursively. Yeah, and all the non-recursive, most of the non-recursive which are executed in the loop, we can put them in a recursive manner, in a recursive function. Yeah, but for recursivity, the loop has to be there. Okay, some set of actions have to be performed in loop to convert it into a recursive function. Yeah, but all the recursive functions we can rewrite them as in a non-recursive format or non-recursive manner. Okay, so the correct answer will be false. Yeah. Okay. So what will be the output of the following code? So okay, so now we are defining this code, and we are just checking recursive functions. Okay, whenever the return statement occurs, let us check what is happening before return statement. So it is printing. Okay, this is again calling recursive function and printing. How many times? Number of times. Or else we are calling recursive function for number -1. Okay, so now let us see what happens when our so we are passing 10 as argument. Okay, so for when number is equal to this, num is equal to 10, so this condition will be false, so this will not be executed. Number modulus 2, num modulus 2 is 0, that means the num has to be divisible by 2, it has to be even number, so 10 is even number, so this condition is true. So we will print star how many times? Number of times. So for currently yeah, our number is 10, so we will print the stars 10 times. So 1 2 3 4 5 6 7 8 9 and 10 times. Okay, and we are calling recursive function for 9. Yeah, so again let us check, this condition is false, this condition is also false, so even these statements will not be executed. Else part will be executed for so nothing is getting printed for 9. Okay, nothing is getting printed for 9. So now we are calling recursive function for 8. Yeah, so for 8 this condition is false, this condition is true, so we are printing star how many times? Because star multiplied by num, so that means we are multiplying the string asterisk 8 times. Yeah, because currently our number is 8, the value of num is 8. So in the next line we will be printing the asterisk 8 times, 7 and 8 times. Okay, and we are calling recursive function for num minus 1, which is 7. Yeah, so for 7 we are calling for 6, we are not printing anything, but we are calling it for 1 minus 7, which is 6. So 6 is even number, so we will print star 6 times in the next line, 1 2 3 4 5 and 6. Okay, and we are calling recursive function for 6 minus 1, which is 5. Yeah, so this condition is false, this condition is false, nothing is getting printed, and we are calling this recursive function for 4. So 4, this condition is false, but 4 is even number, so we will print star 4 times. Then we will call recursive function for 3. So for 3, this condition is false, this condition is false, we are calling the recursive function for 2. For 2, this condition is false, but even condition is true, so we will print the asterisk twice, and we will call recursive for new argument 1. So this condition becomes true and we are printing it once, so that gives us correct answer as option D. Yeah, so yes, almost all of you agree with me except Venkata. You still think it's option A. Option A is this is the option A pattern, this is option B pattern, this is option C, and this is option D pattern. Yeah, so now you agree it will print D. We have seen that if the number is 1, then it will print the star 1 times. If the number is even, it will print star or asterisk those many times. Yeah, because we are multiplying it by number, the asterisk multiplied by number, so it will print those many times. Or else we are for what I can say, the the odd numbers. For odd numbers we are not printing anything. Yeah, so that's why we come to this pattern, option D. Yeah, so shall we go on to programming assignments? This week's programming assignment.
Yes, ma'am.
Yes, yes, Bharatji. So it always performs better than non-recursive. So when we want to have some complex actions to be done or executed, at that time we prefer it to be written recursively. If it wouldn't have been better, why are we using so much of our brain in defining the recursive functions? Because we have to think about the stopping condition. If we write any program non-recursively, we don't have to worry about the stopping condition and anything. So we are thinking more when we are writing recursive functions. So that has some benefits of putting in so much effort in writing recursive functions, because they perform better, they are faster, they are more optimized code, yeah, in terms of output. So when you want to make your code faster, you can use the recursive functions. Yeah, when you want to do some complicated complex actions, then at that time when you want to when you have huge data to be processed, at that time recursive function works better than non-recursive code. Yeah. Okay, so we'll move on to programming assignment questions. So this week the assignment questions were interesting. I have not seen currently what are the programming assignments, so you might be, these assignment questions might not be might be similar or might be little different than the current assignment questions. So we will work on the algorithm, and then I have already written some code for it, and then we will check out the code. Okay, so let's first understand what we are supposed to do. Yeah, so the question goes like this: Aman likes to study about planets. So every night he goes outside to and observes some planets with his telescopes, and then he guesses the distance of each planet and pens it down. So we are measuring distance of each planet from Earth. Okay, let's make it simple. So since Aman is standing on Earth with the telescope, so he is measuring distance of that particular planet from the Earth. He's guessing, not measuring. He's guessing the distance of that planet from the Earth. Yeah. So in this process, he also pens down his favorite planet position. Now, given the distance of each planet to be unique, you need to return the position of Aman's favorite planet after sorting the distances. Yeah. So that means there is so input, we are having the 3 inputs. Okay, one is number of planets, how many planets we want. Then L as the list of the distances, what Aman is noting down. Yeah, list of say planet Mars, planet Venus, and so on. So all these list, so there will be a list which will have the distances of those planets, and K is the position of the favorite planet. Yeah. So now so we have the list L, list of distances. Let's call it L, capital L, right? And we have position of the planet. Yeah. So we have planet position P, favorite position. Yeah. And number of planets N. So that means the length of L should be capital N, right? All of you agree? The length of L should be capital N. So we can use this capital N, number of planets, in place of this length of L, right? These are same. Yeah. So one thing which all of us agree, right? I'm assuming all of us agree because nobody is putting any doubt here, right? So now what we are supposed to, so now in this list of all the planets, we have Aman's favorite planet somewhere. Yeah. So now say there are 5 so yeah, so this is the input. Let us consider 4, 5, 3, 2, 1 is the list we have. There are 5 planets, and Aman's favorite planet is on second position, right? So second position is this 3. So mind you, this is not index but the position. So index is different. If it would have been index, then index of favorite planet is 1, but position in the list is second. So position is how we will assess the elements in the list, and index is how the Python compiler will assess or will access the elements, right? So we will be using the index, the concept of index also, and the position, the word position also here, right? So this is the second element. Yeah. So now what we have to do, we have to check for each element in the list if that element is 5. But when in the sorted list, because currently that element is on the second position, that means index is K minus 1. Yeah. Favorite planet position is K here. Yeah. So this index of K, index of that planet is K minus 1. So now in the for loop, for all elements in L, we have to check if L of I is equal to this element. That means L of K minus 1 is what? Planet, our planet. So that we have to check if that element is equal to 5. Yeah. So how we will get 5? From L of K minus 1. This will return 5. K was the favorite position, which is 2. So index of 5 in the current list is 1. 2 minus 1. So that's why we are doing this k minus 1 here. Yeah, okay, so I am repeating again. So all of you, okay, you agree with this nomenclature that we have the favorite position of the favorite planet as k. So here favorite planet is 5, which is at the second position. But what is the index of this 5? 1, which is k minus 1. Yeah, so that is what is expected out of here. That's why I gave, so Sivadarshan ji, you are right, the output should be 4, but it is given as 5. So that means it is not returning the index, it is returning the position. So position is, right now when we want to have index, we will do it minus 1, but when we want to find the position, we will do plus 1. So at the end we have to return 4 plus 1, not 4 as it is. Yeah, so okay, now let us start from the beginning and we'll come to this doubt at the end. Okay, so now I'm taking Birendra's doubt first. I'm repeating everything from the beginning. Okay, so once I'm reached at the end, I will ask you for the doubts. Okay, so till now I will go uninterrupted. Fine. So we have list of all the distances, capital L. Capital L is 4, 5, 3, 2, 1 for us. We have position of the favorite planet. So position and index are different. Yeah, so index of the list starts from 0, but we will not say the element on the 0th position. We will not say that. We will always start the counting of the position from 1. Yeah, so position will be index plus 1 and index will be position minus 1. Yeah, so how we don't know the distance of this planet, like we don't know at what distance is Aman's favorite planet from Earth, but we know its position. So on second position the distance is 5. Yeah, so we are storing that in say new variable called planet. So planet will be list of k minus 1. So 2 minus 1 is 1. So list at the index 1. So the element in the list at the index 1 is 5. So this planet has the value 5. Okay, so Virendra, now do you agree how we got index and position? Yeah, so position starts with 1 and index starts with 0. So when we want to get the position from index, we will add 1. But when we want to get the index from position, we will subtract 1. Yeah, so that's how this L of k minus 1 will give us the distance from the Aman's favorite planet. Yeah, so now we will check if this is L of I is planet or L of k minus 1. Okay, not k minus 1. We will just make it planet only. So we will check if L of I is planet. Then what we are supposed to return? You need to return the position of Aman's favorite planet. Yeah, position. So that means we are supposed to return index I plus 1. We will be adding that plus 1. Okay, so so this is how we will end. But before that we need to sort this list L. Yeah, L dot sort, using L dot sort, because we are supposed to return the position in the sorted list. Okay, so before we do all this, we have to sort the list. Okay, so now I am taking up Shivadarshan's doubt. So if k is also given as position, we are giving the index. No, I am giving index as k minus 1. That was the whole point. You know, when we want to determine index from the position, we will subtract 1, and when we want to convert the index into position, we will add 1. So here I am returning the position, so that's why I am adding 1, and here I am converting position into index, so I am subtracting 1. Okay, now is it clear? Okay, let's go to code and see. Okay, so yeah, we are asking user input enter the number of planets. Now we are asking user to enter the distances of the planet, the list. Okay, so this third line is getting all the elements of the list from the user. Then in the third line, in the fourth line, we are asking the position of the favorite planet. Whether it is first, second, third, what is the position of the favorite planet. Okay, now we are storing that distance, the value of that from the position of the favorite planet, what value it is storing in the unsorted list. Okay, so L of k minus 1, because we don't know, the compiler will not understand the position, it will understand index. So we need to convert the position into index. So second position, that means for index 1, so we have to subtract 1 from the position. So that's why planet is L of k minus 1. Now we are sorting it, because we are supposed to find that position of that element in the sorted list. So before we search for all the elements of the list, we have to sort. So L dot sort, then for each element of n, L of I, we have to check if L of I is equal to the planet position. Yeah, is equal to planet distance. So when that condition becomes true, we will return I minus 1 here. Sorry, yeah. So here I am returning I plus 1, not minus 1, I plus 1. Okay, and we are breaking the for loop here because we have found that planet. Okay, so when we have found the planet, we are breaking the for loop. We are not traversing through all the elements there. Okay, so let us try to run this code. So last time we had problem running the code. So okay, so let us see. Total number 5. Distances from the planet, let us say 178 space 20 space 43 space 125 space 10. And let us say our favorite position is 43. No, it will again give 3. Let us say currently 5th position. So it should give index of 10 in the sorted list. Okay, so now when we sort this list of 178, 20, 43, 125 and 10, when we sort it in ascending order, the 10 becomes the first element. Yeah, so the output should be position of the favorite planet in the sorted list is 1. It should return I is equal to 0. So now let us check. Okay, great. So it is, so our output is position of the favorite planet in the sorted list is 1. Yeah, so this code is working fine. So you again try to understand what we did. We stored the favorite planet, the value of the distance of the favorite planet from the position. How we calculated the index? By subtracting 1 from the position. We got the index. We stored it in a variable and then compared that variable with all the elements in the sorted list. So this for loop is comparing. For every element we are checking the if condition. For I in range of n is how many times we are conducting. So the index L of I, the index. Yeah, so length of L and n we are using interchangeably here. Yeah, so that is how. So when we are finding that value of favorite element, favorite planet, then we are returning its index plus 1. That will give us the position. So any doubts in this code? Shall we move ahead? Okay, great. So let's go on to second question. So this was the third questions, but it is much easy to understand. So I am taking this up first, and then we'll take the second question at the end. So here we are supposed to write a recursive function. We are supposed to write a recursive function called whole, and it is the argument n. Yeah, this is the argument n, and it should return the sum of the first n whole numbers. Yeah, so we have seen so many recursive functions there in our practice the assignment questions. We had seen so I think I can directly start writing the pseudocode for this function, yeah, or the algorithm for this function. All of you will be with me. I think we can take that risk, huh? Okay, so now we are defining a function called whole, yeah. So now we have to decide what will be the stopping condition for us, right? What should be the stopping condition? When should we stop? So we are supposed to return sum of first n element. So our last element should be 1 if we start from say the argument n, then n minus 1 and so on. If we do, then we should stop when the last element reaches 1, because we are dealing with whole numbers, yeah, integers, all integers, whole numbers. So stopping condition should be n should be 1, yeah. We have to check if n is equal to 1, yeah. So I'll write here if n is equal to 1, what it should do, it should return, what it should return, 1, right? Else, or without else also, okay? Else, let us write else, yeah, else it should return we are supposed to return the sum, so that number n plus, again calling this function for n minus 1, right? N minus 1. Okay, so this should give us the sum of all the elements from 1 to n. Okay, let us see what will happen if we run this code for n is equal to 5. Okay, if we do whole 5, so for 5 this condition will be executed. This is false, then we will come here on this statement, yeah. So this statement will return 5 plus it will call whole with the 5 minus 1, 4, the argument 4, yeah. So for 4 this condition is false, again it will be 4 plus we will call the function for 3. So for 3 this condition will be false, we will come here in else part, so it will return 3 plus we will be calling the function whole for 2, argument will be 3 minus 1, yeah, because whole minus 1 for 2. So for 2 this condition is false, we will again return 2 plus whole minus whole was 1, 2 minus 1, 1. So now if n is equal to 1, this is true, so return 1, return 1. So we are getting addition of 5 plus 4 plus 3 plus 2 plus 1, which is 15, yeah. So our this code or this logic should work. So now let's go to Colab and check. So I'm defining whole, n is equal to 1 will be our stopping condition, yeah. So we are returning n or 1. So here I have written n will be 1, so it will return the same value, it will not make any difference. Now else condition mein it is, we are again calling whole, and now we are taking input, because we have to take input from the user also at the end, and then call the function with the argument n. So capital N is the input, enter the numbers of enter the number of whole numbers you want to add, the first whole numbers, and then I am calling this whole function from the print statement here. So it is calling repeatedly, and the capital N is the value which user is entering. Okay, so let's try to run this. Yeah. How many numbers you want? Say 3, first 3 numbers. So it should return addition of first 3 whole numbers is 6. Yeah, all of you understood? Any doubts in the second program? Aditya, you just unmuted. I couldn't hear what you were saying. Yeah.
Ma'am, no doubt.
No doubt. Okay. So shall we move on to the last question for the day? Yeah? Okay, great. So this is the most fun programming assignment. So we will read this question carefully. So we are supposed to help Romeo and Juliet by encrypting their letters. Okay, so Romeo wants to send a message to Juliet, and he also wants that no one else should be able to read it without permission. Okay, so he shifted all the small letters by 2 position and all the capital letters by -3. So this is -2 and this is -3. So this is what happened in the assignment questions also. All of you remember the assignment question? Let us go back and see. It's not here, no? It was somewhere in the beginning, right? Yeah. Here, now we are shifting by 2 and 3. But it is +2 and +3. But we are supposed to do -2 and -3 here. So we will have the similar code. So you all of you understood here why we had done modulus 26 and all these things, because we have 26 letters, 26 alphabets. So to keep our index within the limits, we do mod 26. Okay, so the similar thing we are supposed to do. Every capital letter shifting by -3, every small letter shifting by -2. Yeah, so if the letter is C, we will shift it by -2, it will become small a. But for capital D, it will become A. But what will happen when C will be capital? What it should become for capital C?
Z.
Z, right? So index of 3 is 0, 1, 2, right? 2. And index of Z is 25. Even though all the 26 elements, the index will be 25. Yeah, all of you agree? So for 2, it should give the answer should be 25. So 2 minus 2 is 0. But we want 25. We want it to be 25. Yeah. But, sorry, 2 minus 3 is -1. Sorry, not 0. I'm sorry, my bad. We are doing -3. Na? 2 minus 3 is -0. But we don't want -0. We want -0 to be 25. So that means we should add 26 before taking modulus. Yeah, all of you agree with me? I will explain once again. So index of capital C is 2. A, B, C, D, E. This is 0th element, first, second, third and fourth. And we are supposed to shift the index by -3. Yeah. So 2 minus 3, the answer should be for capital C. The replacement alphabet should be Z, capital Z here. For capital C, the replacement alphabet should be capital Z. So that means for index 2, we should get the index as 25, the shifted index as 25. Yeah. But how are we calculating? We are supposed to shift all the capital letters by 3. So 2 minus 3. This 2 minus 3 mod 26. This is how we will do it. But 2 minus 3, does it return 25? It should return 25. Is it returning 25? -1 mod 26. It is returning 1. It is not returning -1. Sorry, it is not returning 25. But we want it to be 25. So that means to this -1, we should add 26, the total number of elements, in order to make it round robin. You know, from A, it should go to Z after subtraction. So for A, it is 0. Capital A will become, we are shifting it by minus, no? So X, Y, Z. So capital A will become capital X. You know, capital B will become capital Y. So capital B will have index 0. This will have index 1. This has index 24 and this has index 23. So 0 should become 23, 1 should become 24. So how are we going to ensure that? By adding this 26. Yeah? Because 0 minus 3 is -3. -3, if we add 26, will give us plus 23. And 1 minus 3 is -2. If we add 26 to it, it will give us 24, which is the index of Y, and 23 is index of X. So now all of you understood? No confusion? Yeah, somebody is on unmute. I'm not able to hear. Is there any confusion or should we move ahead?
No, right? So good.
Okay, great. So this was the the major otherwise we all know how this condition will work. We'll import the string and then we'll convert it, the ASCII letters and everything. So that part is there. So we are inputting string, we are asking user input that please enter the message to be encrypted. Then we have lowercase letter, then we have uppercase letter in low and cap respectively. Now we are initializing a string called encrypt to store our encrypted message. Yeah, so similarly we have seen the same thing happening in our assignment question also. So in the for loop, what is happening for every element in the string s, for every character in the string s, if the character is low, if the character is lowercase, so if the character is, if I is in low, yeah, so we are checking if it is lowercase. So we are getting the index of that element from lowercase, the index of that lowercase element, and then we are subtracting 2, adding 26, and then taking modulus of 26, and then we are appending it to our encrypted message by calling that index from the low string, the string called low, which has all the lowercase alphabet stored. So this is what is happening. And when it is uppercase letter, then we are getting the index from the cap, the string cap, which has all the capital letters stored. So in that index, now we are subtracting 3 from that index, adding 26 and taking modulus. Yeah, so this becomes the new index. Yeah, so the new index in the second row of the elif part, else if. Okay, elif is else if. So now we are again using encrypted, we are appending the letter from the string cap, the capital letter of that particular index, which is 3 minus 3 positions. So we have shifted the 3 positions, and now we are extracting the alphabet and appending it into encrypted string. This is what is happening. Now this else part is, we are just, what happens if there is special character in your string, then what it is supposed to do, it is supposed to return as it is, no operations done. So this is what is happening here. Encrypt is equal to encrypt plus equals means encrypt is equal to encrypt plus I. That character, that special character is getting appended as it is in the else part. Yeah, so now encrypted message. So all of you have understood the code. Any problem in understanding the code? Why we have added 26 before taking modulus? We want to make it round robin. Yeah. So should we run this code, or if there are any doubts, I will explain the code once again. I think we saw this in the assignment question, so it becomes easier now to understand. Yeah. So I assume no doubt. So let's run the code. Enter the message to be encrypted. Okay, where did it go? So let us encrypt the joy of computing, and let us use the special character also, the exclamation mark. Okay. So now this is the encrypted message. So it did convert capital C into capital Z, so it is moving in the round robin fashion, and the special character is returned as it is, no operations done on the special character. Yeah, and all the other element are shifted the smaller case 2 positions behind. We can check with the off word, na? So MNOP, so MNO, so O should become N and F should become D. So yes, it is working fine. Yeah, should we run it again and check for some other string, or everyone has got how the code is working here? So if there is nothing to be taken up for the day, we are done for the day. This was the last questions. So this was the last assignment problem we did. So now if there are no doubts, we can conclude the session. Or if there are doubts, you can unmute and speak up. So I assume no doubts. Okay, great. So let us conclude this session today. I'll be sharing the PPT and link to the recording with you all. You can check the Google Sheet, and many of you already know about the channel and how I upload it after every session, so you can check from the YouTube channel also. ठीक है, thank you for attending the session. It was an interesting session, so I'll conclude it here. Let's meet next week. Yeah, so I'm ending the session. Yeah, thank you, bye.